Oh, sweet. We are live, team. All righty.
Great.
All right. Hello, everyone. Whether it's morning, afternoon, or evening where you are, thank you for joining us for Hazelcast's first office hour. Just a quick heads up, this session is being recorded and recording will be available. And if you have any questions during the session, feel free to add them to the chat and Randy or Fawaz will answer them as we go along. Without further ado, over to you, Fawaz.
Thanks very much, Mel. Welcome, everyone. And we're very excited to have the first live office hours today. And just to make sure that you're aware, it's not one time off. It's going to be on constantly basis, on monthly basis. So this is a great news to have. We're trying to do more in terms of the community and our developers and architects. So if you have any suggestion for topics you would like to know more about Hazelcast or you have specific use cases, feel free to reach out to me or Randy or the team, developer the relations at hazelcast.com. And we wanted to figure out the right topic to start the office hours. So we launched 12 Days of DevRel last year, which was a really great community event. And Randy's session for event-driven microservices was the best session we had on the 12 days of 12 DevRel. So we decided to go with this session today. So joining me today, Randy May, our principal architect. Welcome, Randy.
Sure. Hi, welcome. Thanks for having me on this.
How do you feel like your session was the top on the 12 days of DevRel?
Oh, I'm psyched. I hadn't heard that before. So that's awesome. That's awesome. I think people are interested in microservices.
Yeah, it's definitely interesting topic, and especially as we move towards event-driven, I think it's quite important to actually see how it works. So last time we did the session for the event-driven microservices, we decided to do a follow-up. So our first office hours today is gonna cover looking at the code. So I'm very excited to see how it's gonna work. And for anyone joining us now, if you're interested, if you want new, my advice is just not now to go back and watch first session, but also like if you have any question about what we're talking about, feel free to leave your questions in the comment section. We will get to answer all questions. But if you already watched that one, feel free to also follow along for our coding session today. Randy is obviously is gonna do some slides, so I would advise you to also stick around, see the slides, and ask as many questions as you want. And feel free also to share it because we're doing it live. So if you have any colleague or a friend who might be interested in event-driven microservices, this is the right channel and right content. So with that being said, I will hand it over to you, Randy. But perhaps before we start this session, can you just let us know why event-driven microservice architecture is important and what we need to look for when it comes to using event-driven microservices?
Well, I mean, I think essentially the reason they're important is because everybody is, basically looking to get competitive advantage by responding, having their systems respond more and more quickly and with more and more accurate information. And so um, I see it a lot as kind of a continuation of the microservices trend that started more than 10 years ago, where we're trying to get agility by decomposing things into modules, um, but adapting it for the event-driven world that's the reality that we're all living in now.
I guess with Hazelcast, the key message when we develop microservice architecture is simplicity. So for anyone who is new to microservices, don't get frightened with the concept of microservice. We will show you how it can be implemented. And with that being said, I will hand it over to you, Randy, to get it started.
Absolutely. Okay, cool. I'm going to share my screen, but let's let's keep it interactive. Feel free to ask questions. Interrupt me. That'll be better. But there's enough content here, so I thought what I would do is just start with a short recap, just to kind of level set where we're at, and just talk a little bit more about event-driven microservices. And then we'll do a demo of an implementation of this with Hazelcast, and we'll look at the code, and hopefully there'll be lots of questions. So with that, let's get started. Okay, so an event-driven microservice, focusing on the microservice aspect of it. I see it as being, this is my own definition. I don't think it's very controversial though. I see it as being something that implements a cohesive set of business functions that's independently deployable. And the event-driven part is just that it consumes and produces events, like as opposed to responding to requests. So some of the main principles, and we talked at more length in the previous session. So again, this is just a recap, but if there's any questions, please chime in. Some of the main principles are, and this one I think is really interesting and valuable from an architect perspective. Events are the interface, not APIs. This is kind of strange, at least to me. I've been developing software for a long time, and but we'll see with an example that, basically it really changes the way things are coupled. So events are the interface. That's one thing. The next thing is that I think a purist would say data stores are kind of secondary, and the source of truth is event streams. I think most people realistically would say that data stores can be constructed or reconstructed from event streams. So data stores, at least in theory, are kind of projections of event streams. And you can, since we have event logs that can go back in history, you can reconstitute data stores from event streams. So that's another principle. One thing that I really like about event-driven architecture is that interactions are inherently asynchronous. It's built in, and I'll talk about that a little bit more, but it's very important from a performance throughput point of view. And then the last thing is there's always this bridge that you need to make between your legacy systems and your microservices. And one great way to do that is basically use CDC to liberate, so basically take a legacy data store and turn it into a stream that can then be consumed by your event-driven microservices. So those are some of the key principles. Now, I've got a little illustration here. So if we say, and it's going to use retail because everybody knows that domain, and we're going to just kind of look at, compare and contrast service-based versus event-based from a couple different perspectives: resilience, coupling, and performance. All right, so a typical order service might have to interact with a payment gateway, an inventory service to adjust the inventory level and reserve inventory or maybe release it out of the shopping cart, and a shipping service to initiate fulfillment. At least that to start with. And if we just look at this from the three considerations, let's just go through each one. So one is resilience. So what happens if I'm receiving an order, I've called the payment service. The payment service has responded. The inventory service has responded, and then the shipping service isn't available. In a strict kind of request-based architecture, what do? We could fail to take the order. We could just say, sorry, you can't take that, which is undesirable. Or we could go ahead and take the order, but now how are we going to make sure it gets shipped? We'd have to somehow log an event or something, right? And we're already headed toward event-driven. But there's no the request response lacks this kind of buffering, and so it can make it brittle, especially as you compose services.
Hey, Randy.
Yes.
Just about the previous slide, if you don't mind, we got a question about the CDC. Could you just explain what CDC is and the use case for it?
Yeah. So there's different ways to do it, but it stands for change data capture. And when actually, you know what? Let me, I have a good use case for it. Let me not skip this slide. All right. Okay. All right. So when you're let's suppose that we have a monolith, right? And again, it still orders. And we said we want to make an order service, right? And so the order service, and we want to do it in an event-driven way. So the order service, we know it's going to take orders, and I'm going to go ahead and give it a synchronous REST API for the shopping UI to hit, because we don't have to, everything doesn't have to be events. And the order service has its own customer store, and that's for agility. That's typical of microservices. But how does it get that data? So that's the question. And so this is where CDC comes in, and this is this phrase that I use, liberating the data. So basically, I want to I want to be able to access that data that's in my legacy database. And there's the way, and again, it stands for change data capture, and it basically takes a legacy system and converts it into a store, and converts it into a stream. And like some of the most efficient ways actually integrate with the database log. But there's different, it's also possible to do it with triggers. There's different ways to do it, but the whole point of change data capture um, is to liberate the data so that other systems, and basically turn it into events so that other systems can consume it. So hopefully that answers the question.
Yeah, I think so. Thanks, Randy. Hopefully, this is clarified for you, Mark. If you still have a follow-up question, feel free to use the chat box. And for Henrik, I think we do see the screen. So my advice for you now is just maybe use a desktop client instead of the web client, because we do see the presentation. So over to you, Randy.
Okay. All right. Let's see. So we were talking about, I talked about resilience. Let's talk about coupling now for this architecture. All right, so it's not really that bad, but the order service does have to know, clearly it's going to call their API. So the order service has to know about the payment service, the inventory service, and the shipping service. And it's possible that when they change, they could impact the order service. And you would have, if you're testing the order service, you would have to at least have stubs for all of these. So, and we'll see in the event-driven world that this is actually different. And let's think about if we want to add a notification service. Your order has shipped, or your order has been accepted. So again, the order service has to be modified, and the shipping service has to be not modified. So there is a certain level of coupling there. And then lastly, performance. And the main thing I wanted to say about performance is, if these interactions are synchronous, they don't have to be, but that's the easiest way to, and a lot of times they end up being synchronous. Then as you chain synchronous service calls, you can end up with threads that are just doing a lot of waiting. And so you can end up with a system that can't use all the CPU. There's more CPU available, but it can't process more orders, because there's a lot of, once you chain enough things together, there could be a lot of waiting in the system. So there's always this hazard with synchronous invocations. All right, so contrast. Okay, so let's talk about an order service. And in this event-driven model, the order service's job is only to take the order and to publish what happened. And because I want to be a little bit realistic here. I think probably before you take an order, you're gonna access the payment gateway, and that's probably going to be synchronous, and that's okay. No architecture is purely event-driven or purely request response. But the order service's whole entire job is just to say this order was placed, and it publishes that on a topic somewhere. Okay. And then the inventory service subscribes to that topic and does whatever it needs to do. Same with the shipping service. So let's look at that again from these same three perspectives. So from a resilience point of view, the problem I talked about before, where the shipping service is down, is not a problem anymore. If I need to update the shipping service, or if it just happens to be down, the unprocessed order will just sit here until the shipping service is back up again. So you've got this buffering and resilience built in. That's I think a really nice property of event-driven systems. And then from a coupling point of view, actually the order service doesn't even know about the inventory. It doesn't know about its downstream consumers. Its whole job is just to publish an order. And if I want to add a notification service, I can do it without actually modifying the order service or the shipping service. So this is what I was talking about. Instead of the APIs being the interface, now the events are the interface. Clearly, those have to be designed as carefully as APIs have to be designed, but it does provide a degree of decoupling. And then lastly, about performance, event-driven systems are async from by design. It's built into the platform. It's not something a developer would ever have to worry about because it is built into the platforms. So that problem with synchronous calls, chaining synchronous calls doesn't exist in an event-driven world. So typically they'll scale better. Okay. All right. And we just did this one, so I'm gonna just skip over it. We did that one out of order. Okay. So now I just wanted to do a quick progression of how do you implement this, like platforms and technologies, and start in one place and end up not surprisingly, I'm going to end up with Hazelcast as a platform. But this is a place where a lot of customers would potentially start. So basically, all of your business logic is in an app server somewhere. Because you can certainly use an app server to process messages just as well as you can use it to process requests, right? So all your business is an app server. Business logic is in an app server. And almost always you're going to have some kind of fast data layer, cache, whatever it might be, because beating up the back end database, if you're constantly retrieving entitlements or customer profiles or whatever it is, and out here you've got web facing traffic. This is very high volume, and you can't just simply pass these little requests back through to a database. In order to make your website responsive and in order to not beat up the database and in order to be more resilient, typically you'll have a fast data layer. So we're going to start here, but then I'm going to propose a couple of modifications or even upgrades, I'll say. Okay, so the first most natural thing is let's use a stream processor to process events and rather than an application server. And I'm going to talk a little bit. I don't know if we can take a poll, but I'd be curious to hear how many people are really familiar with what is a stream processor. I'm going to talk about that next. But in short, it's something that's designed from the ground up to process events, and it can do some things that app servers can't do. And some of those things are like deal with state, like if you want to do aggregations, if you want to do average something out over the last 10 minutes or the last 10 hours. That's not something that's easy to do in a stateless microservice, but it's trivial to do in a stream processor.
Hey,
So
Randy,
yeah,
can you explain what fast data is? Are you referring to caching here, or are you referring to something else? Just a question from the viewers.
okay, yeah, I think by and large we can call it caching, but it may, I've worked on plenty of applications where you have a fast data layer and it's not disposable. Caching, at least to me, caching implies disposable, like the system will still work without it. There's a lot of cases where it's just infeasible to actually run the request all the way back to the data store. So, and there are a lot of cases where you have in this fast data layer, you have like kind of a assembled view of the relevant business data, right? Like, so it's not just a cache in front of a data store always. It could be some constructed view, what's a good data, like a data fabric, basically. It could be a data fabric as well.
Yeah.
So.
Well, I think it makes sense to actually distinguish between the two. So what we mean here is kind of like looking at your data. Every time you do compute, when your data in memory, you move from cache. So it's not cache anymore. And what we refer is for fast data, essentially you're doing something with your data, regardless what you're doing with it. And it is in memory. So we're not storing data only for memory, but also we're doing some kind of compute or transformation for the data on top of the actual data. So that's why we call it fast data. Do you agree here, Randy?
Yeah, in fact, you kind of that's where I'm going. But this is part of the progression, but unless like I have two more steps to go, and I totally agree with what you said. So step one, what if we just decided that an HTTP request was an event? Treat it like an event. If we did that, then all of our business logic could be in a stream processor. And I actually like that for the reasons that we talked about, basically it being inherently async. Um, you basically you worry about the business logic and the stream processor worries about state scaling it and deploying it. But our data in this architecture is still a hop away. And there are very few, there's only one that I know of, products that actually um, unify these two layers, the stream processor and the fast data store. But this is exactly what Hazelcast does. And you can imagine the efficiency. So now we have the data access and the event processor together. So, for example, if I need to process a credit card, I'm going to need to maybe look up the customer's credit limit and a bunch of other things about the customer too. So when that event comes in, it would be ideal if that event could be processed where the customer profile actually lives. Like, customer profiles in memory, maybe in this node. It'd be great if the credit, if the credit swipe was processed on this node. So that's the advantage of having a unified platform is it's
I want to stop here, Randy.
yeah,
Essentially, it's not a question. It's more kind of like observation when it
yeah,
comes to discussing unifying these two components. So can you just describe why this is important? Why it is important just instead of having two separate solutions or two separate platforms, one for fast data and one for stream processor? Why it's important to combine between the two and have it in one unified solution? And essentially, what
yeah,
users, like the viewers now, what they get when they have it in one platform?
yeah. Well, and I would say one thing is that, just because the industry evolved these certain categories doesn't mean that's the only way you can build software. And so in some ways we're kind of disregarding the categories. And but the two advantages in my mind are speed and simplicity. Like the speeds, comes from co-location, no serialization, no network hops, or fewer serializations and fewer network hops anyway. And simplicity, just less to manage and um, less to monitor, less to purchase, less, one source of support. You've got these advantages kind of in terms of cost of ownership and time to market because everything's just simpler.
Sure. So this is great to hear. And for anyone who is new to unifying stream processing and fast data store, we actually have three different workshops to get you started. So it's even a level before event-driven microservices, which is gonna be led by Randy as well. So if you like Randy and you would like to know more about Hazelcast Essentials, we do have three different workshops, so we'll send these links. So feel free to sign up on our workshops, live free events, and it's going to be also online, so virtually, but also you can invite your friends and colleagues. So this is a great opportunity to know how you can do a stream processing as well as fast data in one unified platform. So over to you, Andy.
Yeah, totally, totally. Yeah, today we're going to get a little taste of it. We're going to look at the code, but in some of those workshops, some of those workshops that you mentioned are actually hands-on, and so you'll have a chance to actually do it yourself, which is always best. Okay, so that's kind of our view of the best way to do event-driven microservices. Now, like I said, I wish I could take this poll. I don't know how many people are familiar with stream processors. The most well-known example is Flink. Um, but I'm going to just do a short, probably less than 5 minutes. What is a stream processor? Just to kind of get everybody on the same page. Then we'll look at a demo and some code. Okay, so with a stream processor, your unit of business logic, which your service, we call it a pipeline. That's just what we call the API. And pipeline is a graph of tasks. And this one's completely linear. They don't have to be completely linear. You could have branching graph and things. But so anyway, it's a graph of tasks. And if you're familiar with Java streams, it's actually pretty similar to Java streams. So only, of course, it runs distributed. So events flow along the vertices of your pipeline, and each of these little boxes, you provide a piece of business logic that processes the events, and the stream processor manages deploying this all out to a cluster and scaling it. And so if we look at the pipeline below, this is meant to be really, it's meant to be really simple. So we're going to read input from, it could be anywhere. I think this says a file. Maybe we'll parse it. That's another step. Then maybe we'll do an aggregation. That's another step. And then finally, we'll write it out to a database. And that's another step. So you basically write a piece of code that has these 4 steps. Okay. And your options here are kind of, this is pretty intuitive. I think you've got a source that produces events. You've got a sink that consumes events. Like that would be if you're writing to a database. You've got a map that just transforms events. Got a flat map that changes one event into multiple. An aggregate that takes multiple events and maybe computes some kind of aggregate over a window or something. And a filter, that's obvious what that is. So our API basically parallels that. And one difference between our API and say the Flink API is it's heavily functional. We rely on lambdas a lot. Flink relies on implementing interfaces. It results in some very kind of it can be a little hard at first, but it's some very minimal code, and it's really nice. So yeah, so just to recap, you define the pipeline, Hazelcast runs it, and you don't have to worry about a lot of the distributed computing problems. Like, so you just provide a little piece of logic that processes the event at each stage, and it will be parallelized. It'll be run in a location-aware way, and it'll be fault tolerable. And the platform gives you the ability to like basically temporarily stop the stream, take a snapshot, upgrade the logic, and resume where you left off. And the whole thing scales by adding nodes. So this is just an example. We don't need to like parse this in every detail, but this is on a 2-machine cluster with 2 cores each. It might deploy the pipeline that we saw earlier, something like this. So it's doing the scaling for you, and it's doing a lot of smart things. There's a great, this is actually a pretty cool read here in our documentation that describes how basically how Hazelcast schedules tasks. So it's worth checking out. So, but the main idea is you define it and Hazelcast deploys it and scales it for you. And other event processors work in a similar fashion. Okay, so now let's take an example. I'm just going to give you the context and then whiz through this here. So basically, this is going to be telemetry from a factory floor, and I wanted to show one service that is event driven. And so the first service is just going to digest and summarize telemetry. Like, this second, here's the temperature reading from this machine. We'll have a stream that is like that, and it needs to be digested. And so that's one service. And then the other service is a request response. I want a REST URL that'll let me check on the status of a machine if I provide the serial number. So it looks like the architecture looks like this, and then I'll actually run it. So yeah, time-wise, we're perfect. So basically, the gray boxes are pipelines. So they are things that you write and you deploy, and you deploy them to a Hazelcast cluster a lot like you would like a jar to an application server. So they're just a jar. And you write these and deploy them, and like I said, you can update them and whatnot. So just to kind of belabor it a little bit. So the first one is processing events from a Red Panda topic. And the whole box doesn't, inside the box are the steps, but it doesn't matter. This is the service. The box here is the service. And what the service does is it computes a 10-second average. It looks at the temperature reading that's in the event, computes a 10-second average, and stores it into a Hazelcast map. It's a map in memory that's now accessible to sort of the rest of the world. So that's that service. And then the other service is basically going to be a request response service. And so we have a little library that we use to turn a REST request into an event. Basically, so that pipeline reads the event. It looks at the information from the current machine status that was written from this pipeline. And it also combines it with information from the machine profile, like what are the expected readings for this machine as it's currently configured, right? So I take those two pieces of information, I combine them, and I give it a red, green, a red, green, orange type of status, and I return that. So those are my two services. One is processing events, and one is processing requests.
Hey, Randy.
Yeah.
So we've got a question, like I think the answer is coming, but it's worth mentioning it here. So is it possible to try this example on the user's machine and how they can access code? Maybe you can just highlight that. So we're gonna provide also links, GitHub and so on. Thank you.
Okay. Yeah. So this runs on Docker Compose. I just let's see, maybe someone can drop the link for the GitHub repo. I think it's actually right here. Anyway, maybe someone can drop the link for the GitHub repo into the chat. But yeah, there's a GitHub repo where this lot lives. It's called Microservice demo. And
yep. So to answer your question, Christian, yes, we will provide the GitHub link for it, so you can try it out on your machine.
Yep.
And we will follow up after this session today with all links, so you don't need to worry about it. So you should have the option to clone this project and run it locally on your laptop or computer.
Yep, absolutely. Okay, so what I've started here is quite a few things, actually. I'm not sure if, hopefully this is readable, but so I've got an event generator, and I've got a Red Panda broker. Then I've got a Hazelcast cluster and Hazelcast Management Center and performance test and this actual status service itself. So we're going to see all that in just a second. So if you haven't seen it, here's the Hazelcast user interface, and we've already got, and so if you kind of look down the left-hand side here, the first panel here is about the members, the machines in the cluster. The second is about what's in memory. And so even though I talk about maps and they're the most popular, there's there are quite a few other data structures that are useful, like even just locks and lists and things like that. Then the stream processing part is what I wanted to show you. So here are the deployed services, and I'm going to deploy another one in a second. These are dynamically deployed, and you can get information. So this one here is the aggregator. It's the one that's processing the events from the factory, and and you've got quite a lot of visibility here, so you can actually. So here's a graphical depiction of the pipeline, and you can actually click into a part of it, and you can understand, for example, how many actual instances are deployed, and the data flow through each one. So it's pretty cool. Let me back out of that, and then what did I wanted to show you? I want to grab so Hazelcast maps are you can map them onto SQL. So here's an example of that. There's a map called machine profiles, and it's just got the information about the machines, like who's the manufacturer and what's the warning temperature and what's the critical temperature. So I'm going to take one of these serial numbers, and we're going to plug it. Let's run the service now. So I have Postman. So here's Postman. I'm going to just plug in that serial number that I just took out of Hazelcast, and It's just running locally. It was one of the things that was started. And that's interesting. It actually copied my little return. Don't like that. I'd rather that be gone. There you go. There you go. Okay. So you can see here that there is a web service, and let's just look a little bit about. I'm going to run it. We'll just run it a couple times, and then also I'd like to do one other thing in the background here. So we invoked it manually, but let's invoke this web service continuously. So as I make changes, we can see it doesn't break anything. So this is something that is just going to hit that web service that I just hit with Postman. It's going to hit it over and over again and record the metrics. So and we'll be able to tell the response time and whether or not there were any failures, and we'll just leave that running in the background. Okay, so going back to Hazelcast, what I wanted to show you is that I mentioned that maps are mediating the request and the response. So basically, there's a pipeline. The pipeline that's processing a request and response is basically feeding off of these two maps here. It's getting input from the request map, and it's getting output from, or it's sending output to the response map. Okay, and so one thing I wanted to note is that we can also change these without any downtime. So this thing here doesn't have a status. So this isn't a very good service. Let's deploy another service. So if you're not familiar with Docker, let me just show you something really quick. Docker Compose. So Docker Compose is just an orchestration for Docker commands, basically. And so what I'm going to do here is I'm going to somewhere it should have a command to run a new service. Yeah, there you go. Submit status service 2. So I'm going to run this command, and it's just going to submit a jar that we already have to the cluster. Docker compose run. So now, oh, guess I should have copied that. Okay, so that's just connecting to the cluster and submitting the jar. That's done. Now, if we go back and look at the cluster and we look at the jobs section, we're going to see there's not 2 jobs, there's 3. They've got this new one, status service, but it's not processing any events. And that's because there's a routing configuration. So the routing configuration is simple. It supports blue-green types of things. So I'm going to dump the routing config so you can see it, then I'll update it. Dump routing config. So all this kind of converting a HTTP request into a Hazelcast event is all mediated by a library that's also out there on open source. Okay, so we have a service called machine status. This is the routing information, and it's saying send this weight to V1 and this weight to V2. So that's why we're not getting any information on V2. So now I'm going to load the routing config, and we'll start, and I'll just send all the traffic to the second implementation. So we'll start doing that. Okay, and that looked like this, right? So it's just same exact file, but now there's 100% to V2 and 0% to V1. Okay, so now if we go and we look at the Hazelcast UI, we can see that this one is now getting traffic, and that one's not. And I could have split it, right? I could have split the traffic, but I just switched it all over. And if I actually go back to Postman and send the same request, so right now, notice there's no status. So if I send that same request again, so okay, clearly I've updated the implementation because now it's returning a status of green. And if we go back and look at the test client that was running continuously, actually it's a little easier to see over here. There's no failures. There wasn't really even a deviation in the response time. So anyway, that's the demo. The next part is to show you the code, but basically, yeah, that's just a demo of two simple services, one processing events and one processing requests. So next is code. Any questions about that?
I guess we can take one of the questions here. So essentially, because you cannot describe the code, one question came up here is, I know that it's a Java. What programming languages you can use for these type of solutions and why?
Okay, so you can only there's two options for pipelines. One is Java. That's by far the most flexible, and the other actually is SQL. Believe it or not, there's another workshop where we'll show you that, but you can actually make pipelines using SQL, and it's actually pretty cool, but it's not as rich as the Java one. And so you can do things like, for example, in a pipeline, you can call out to Python, and we actually have a specific Python runner capability. But the overall pipeline has to be Java or SQL. So, all right, let's look at the code, some of the code. So this is the code for. Hey, is this big enough? Does this look big enough?
Yes. Yeah, it's
Okay.
fine. Thank you.
Okay, so this is the code for the pipeline that aggregates the events. Okay, and so first, the main is kind of boilerplate. It's just this pipeline is as you can see, it's a Hazelcast API. So we create a pipeline that we're able to pass in parameters. In this case, it's going to be the Kafka topic and the Kafka connection information. And basically like I said, this is just boilerplate, and then you're able to use Hazelcast command lines to deploy it. So all the interesting stuff is in this create pipeline. And it goes in steps, and got a lot of documentation, I've got a lot of comments in here. So it's a fluent API. You can actually chain all this, but it may be a little easier to understand if you don't chain it. So let's just kind of look at it step at a time. So first thing I'm going to do is I'm going to create this stream source, and we have a built-in source for Kafka. So that's one line to connect to Kafka and provide the stream source. Okay, and then the next thing I want to do is I want to read stream of records. So this read from command produces a stream that that's like the first box in the graph is to produce a stream from Kafka by reading Kafka. Okay, so then the next step is going to be to parse it. And so this is the code that does the parsing, and it's using Jackson. And so you notice the command is map using service. So it's still a map command. It's just transforming the input from one form to another. In this case, what went in was map entry, and what comes out is a piece of parsed JSON. There you go, stream stage of JSON. So each step returns a stream stage. Okay, so and then map using service, anything that I want to share. So like I don't really want to inside of my each time I process events. Imagine I'm trying to process hundreds of thousands of events a second, let's say. I don't want to be creating a new object mapper every time, even though it's not very costly. So anyway, so that's what map using service is for. It allows you to take some external context and inject it, create it once and then reuse it as you process every single event. So anyways, this is the Jackson object mapper, and you see there's very little code here that doesn't have to be here. It's all 95% of this code is your code, basically, and usually it's provided in the form of a Lambda. So So this map using service step, basically it takes an event and it takes the OM as object, and it takes the object mapper and it just calls that API on it. So that step, now we have a stream of JSON nodes. Now we want to aggregate that stream of JSON nodes. Okay, and so see the name of the stream is JSON. So I'm going to say JSON. I'm going to apply a grouping key. That means I'm not trying to aggregate every single event ever. I'm trying to aggregate by machine. So I provide a Lambda that pulls out the grouping key. In this case, serial number. So I'm going to get this aggregate per machine. So I set this grouping key, and the other thing this is going to do is it's actually going to cause it, when it actually calculates the windows, it's actually going to cause it to route to the node that corresponds to that key, that serial number. Okay, and so we have built-in window definitions. So we're going to say apply a grouping key, and then we're going to define a window, and that's just going to batch those events up into windows. In this case, it's going to be a tumbling window, 10 seconds long. And then for each tumbling window, it's going to compute an average. And we're just saying, I want you to take the average of the bit temperature, something I read out of the event. And this is just for documentation, set the name. So this stage returns a keyed window result of basically for every single window. As the window tumbles, I'm going to have a serial number and I'm going to have this average temperature. So that's what this stage returns. And we take that stage and we apply, we process that stage. So the next stage is this is creating a generic record. It's like a row. It's a way that we can basically create things that can be consumed as POJOs, but we don't have to have the class. We don't have to have the class on the server. So basically, this might be a little cryptic, but basically we're going to take the keyed window result, and we're going to create this object called it's going to be what is it? It's a generic record of the machine status summary. So I will just quickly pop over to that. It's just a POJO with serial number and average bit temperature. That's the and we can read that as SQL, or we can actually read it as a POJO as well. So anyway, so we create that, and then the very last stage is to take that machine status summary generic record and we write it to a sink, and the sink in this case is another Hazelcast map called status summary map. So that's a little taste of the pipeline API. We've got also the request response API that we can look at as well. But before we go any further, any questions? Did that make sense?
Yeah, I think this is a really interesting topic, and I think this what is important at this moment is just to mention our 3 different workshops. So we have the Hazelcast Essentials. If you don't know anything about Hazelcast, this is the right workshop for you. If you already know what Hazelcast is and what it does and why it is important to use it for event-driven architecture, and you would like to know more about this topic in this session today, we have dedicated training with Randy about event-driven microservices. So make sure to sign up with that one. And also, if you're interested in data streaming with Kafka and stream processing, we have third workshop also to get you going as well. But in all cases, regardless where are you in this journey, feel free to leave questions here or follow up at developer relations at Hazelcast. We are happy to answer any question, and make sure to sign up for the community Slack, where you can also access our solution architects and engineer and ask question about these solutions.
I can put that back up. If there are any questions, I can put that back up just so you can. Okay, let me just whiz through this. Yeah, so there are QR codes for our Twitch and our Slack communities that you could join, and
That's
I
great.
think all these links are also are also being put into the chat.
Yeah, I think it's nice here, like if you're watching on laptop and you have your mobile, so grab it and scan it.
Yeah.
Or, yeah,
Yeah.
or just Yeah, or just take screenshots from this. Maybe the follow-up slide around is the one with workshops and links on it. So also, like for example, if you want to take screenshots, so these are the 3 workshops we're running, as well as where we can access the GitHub. So this is kind of like a really important, depending where you are in journey. It's very important. It's also to enhance your career as well. So we got a couple of questions, if you don't mind, Randy.
Yeah.
So you mentioned Hazelcast Docker, and the question is here, how are the options for Hazelcast deployment? So
We have a lot of options for deployment. So you probably know, well, in case you don't know. So one, you can always just directly deploy it as a jar. You can deploy it embedded actually in for example, inside of a Spring Boot app. That's probably not the most popular way to do it, but that's an option. And then basically anywhere that a JVM runs, you can run it. But we also have a lot of help for you if you want to run it in Kubernetes. So if you go to Docker Hub, there are regularly published images for Hazelcast and for Hazelcast Enterprise and for the Management Center. Those are all up to date, and they kind of have some of the best practices and settings baked in. And that's actually all as for this demo. And that's basically what I use almost all the time is I use those Docker images. So that saves you a lot of hassle. And then on top of that, if Kubernetes seems to have kind of won the cross-cloud platform battle. And so we are putting a lot of work into Kubernetes. We have a native operator, we have a Helm chart, and those all have a significant investment in them. Yeah, so basically it's pretty, if you're part of the Docker or Kubernetes ecosystem, it's pretty easy to run.
So this is great to hear. So if you're getting started, I would say download Hazelcast on your laptop or computer, play around with the local cluster, see how it works, download Randy's demo from GitHub. But the second question we have actually, Randy, what is your recommendation for event-driven microservices when it comes to deploying such solutions?
So I think so, especially for event-driven microservices, I think Hazelcast pipelines are essentially, I think they're equivalent to event-driven microservices. So they kind of do everything you want a microservice to do. They're modular. They can they're a modular piece of code that encapsulates a business function, and they consume and publish events. So I think and you've got the fact that you've got this simple platform that combines a data store and an in-memory compute and a stream processor all together in one simple product. You don't have to integrate anything. So yeah, my recommendation is more or less event-driven microservices equal pipelines.
Yeah, I remember my old days when like I used to use multiple tools to, write a application where it becomes really hard to every time you need to learn a new platform and then every time you
Yeah.
need to upgrade and maintain. So like having it all in one place saves a lot of efforts and time. So I think this is a really interesting and great about using Hazelcast. So listen, Randy, thanks so much for your time. I think this is really interesting. So I would love to try it out myself. So I'm gonna download your GitHub repo. And essentially, it's not IoT, right? So it could be applied to fintech. It could be applied also to machine learning and AI and all sorts of things. Is that correct?
Yeah, that's correct. That's just the topic I chose because it seemed interesting. But yeah, absolutely. You could clearly see how this would apply to like fraud detection, all sorts of applications in fintech, especially. We have a lot of fintech customers. Yeah.
So any final thoughts, Randy, before we finish off today?
I think that's it. Yeah, I hope that it was informative, and go download go clone the GitHub repo and let me know what you think.
Yeah, we got like one final question, if you don't mind.
Yeah.
So, do we support like distributed microservices?
Yes. So when you write a pipeline, so what, the reason you distribute things usually is for scale. So when you write a pipeline, basically you just write you write the steps, the tasks, chain them together, and then Hazelcast deploys them at scale. I mean, so we've been actually, across the whole distributed system, we've actually got benchmarks that go up to 1 million events per second. So it's and that wasn't a limit. That's just where we stopped testing. So, but I should have included that link somewhere. But it's pretty impressive. It's a very, in my opinion, it's a very well designed platform for doing event processing.
Yeah, and obviously this is the follow-up question across multiple availability zones. So yes, obviously, so we do support multiple AWS zones. And with
Yeah.
that being said, thanks so much, Randy, for your time and for this demo. I think this is really important. Sometimes you have the theoretical part that you don't get the implementation. So getting to know and play around this code on GitHub is a great thing to have. If anyone watching us in recorded mode, don't worry if you still want to ask questions. We're available online. Our community newsletter is one way to actually get access to us. Also a community Slack, but also use developer relations at hazelcast.com where you can ask questions. Feel free to find me online or find Randy online on LinkedIn as well. LinkedIn as well. So this is a great resources. We're available. Just tag us, and we're happy to answer any question. And because we want to listen from you, if you have any interesting topic, or you would like us to cover a specific topic with Hazelcast, stream processing, and real-time analytics, machine learning, and AI, feel free to reach out to us. And speaking about machine learning and AI, I'm very excited to have the second office hours of Hazelcast running up next month. I believe it's March 28th, where we will be discussing boosting similarity search, vector databases with stream processing, which is quite important. What vector databases and vector search can provide, what are the limitations, and how you can use stream processing to your advantage to solve challenges for vector search and vector databases. So thanks for everyone joined us today. I hope you had something useful today. So my advice to you is go home, download Randy's repo, play around with it. If you got stuck, feel free to ask questions, and make sure to sign up for our live workshops. And I will see you next time. Thank you.
Thanks, Fawaz. Bye.